So hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where everything is being taught to you completely in English. All right, so today this is a series that I host for class 11 students, and today we'll be talking about rigid body motion and analysis of pure rotation. And today we'll be talking about the all the methods, the summary of analysis of pure rotation. Okay. So first of all, before we get started with today's lecture, let me introduce myself for those of you who don't know me yet. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE exam. And all this experience, all this teaching had been offline. So, however, offline, I have been associated with some of the topmost institutes in the JEE coaching industry. And I myself, as a student, had secured an All India rank of 447 and an All India rank of 192 in the two stages of the IIT JEE exam that I took. Then I also qualified at the NDC Stage 2 and I was in the top 1% in the NSCP, which you better know as the National Standard Examination of Physics or Physics Olympiad. Now, I also have coached many students to top ranks in the IIT JEE examination, both mains and advanced, in the offline setup. And here I hope to continue doing that online with you guys. All right. So, how can you guys make sure that you are getting the best of the preparation and guidance for your JEE battle? So this is how you do it. You can get yourselves the Unacademy subscription. This subscription will get you benefits like live classes where you will get to interact with your educators. These classrooms also have live polls and leaderboards, which keep them highly interactive and fun. Then you have test series and analysis sessions, which keep you on your toes regarding your preparation and your standing in the JEE battle, like, as I keep saying. And of course, you have live doubt clearing sessions. So this is a very, very important part. So as a matter of policy, all Unacademy courses have a doubt clearing session after every three teaching sessions. So your doubts with Unacademy courses never pile up and they're always taken care of. Now, along with all these benefits, Unacademy also provides you the opportunity to study from the best educators all across India from the comfort and safety of your home. All right, so these are the ongoing courses which are being conducted by the JEE English team for JEE and Advanced Mains and Advanced 2022. So these are three courses of class 11 topics which you can enroll in once you have your subscriptions. So there is detailed course in on graph sets and relations by Abhinav sir. Then there is advanced course on redox and equivalent concept by Rahul sir. And I myself am taking a course on which is an advanced course on mechanics. Then you have four courses for 12, class 12 topics, which are mainly for JEE Mains and advanced aspirants for 2021. And these include advanced course on electromagnetism, which is I am taking, and three other courses. All right. So how do you enroll in these courses? Hi Rajesh, how are you? And how can you make sure that you are propelling your JEE preparation? So you need to get the subscription, and this is how you do it. First, you'll need to install the Unacademy app. Or once you've done that, you can go to the plus section of your app, select your goal as IIT JEE, and click on the Get Subscription button. Now, when you do that, you'll be redirected to the payment page where you will realize that the fees of all the courses or all the subscriptions is kept at a very, very modest rate. Okay, so any reputed offline coaching institute, trust me, will charge you anywhere between 4 times to 8 times this fees. So I can tell you from experience because I have been a part of offline coaching institutes for almost 8 years. So Unacademy is providing you the same quality education from the same top educators at a very, very competitive price, which will be made even more affordable if you use this code. So here you will have a section which will say you have a code. That is where you can use this code RD Live and you can get an additional 10% off. And once you uh, click on proceed to pay, you will also realize that you have a lot of no cost EMI options to break down your payment into easy installments. Right. So make sure you are getting this subscription and benefiting out of all the features of the Unacademy Plus. And to remind you that Unacademy is also hosting the Unacademy Combat, which is the most competitive gamified version of IIT JEE Battle. And it will be hosted live. The next Unacademy Combat will be hosted live on the 22nd of November. So you can participate in that. You can enroll now by using the code RD Live. And if you do well, you will win yourself a lot of rewards and prizes. Okay, so make sure that you're competing there. And not only realizing where you stand in the competition, but also win yourself some cool prizes. All right, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. This will help you receive all the notifications of all the sessions and lectures happening on the JEE English channel of YouTube. All right, then, without any delay, let's get started with our discussion of the topic rigid body motion. Today, we'll talk about analysis methods of which include work energy methods and all other methods. Okay. So far, good evening, S. Pandey. So far, what we have been doing is that we have been focusing on understanding the dynamics of rotation, how rotation is governed. We were building up concepts of how to write torques, how to write angular momentums. Today, we will briefly just summarize everything and then realize how we can solve problems using all the approaches that we have learned so far. Okay, so there it is. The topic for the day is analysis of pure rotation. So enough of building up the concepts. Let's put them to use and start analyzing pure rotation. So what are the approaches? So first of all, you have torque and angular momentum equations. So first case that you may have is equilibrium. So if a body is in equilibrium, and then how do you analyze it? You know that there are two conditions for equilibrium. So first you will write all summation f vectors would be zero. This will ensure translatory equilibrium. Okay. And then second part is that summation of all external torques is also zero about any point. Okay, so these are the two equations that you can write and solve any problem where equilibrium condition has been given. Okay, this ensures rotatory equilibrium. Now, point you should remember is that this is true about any point. For rotatory equilibrium, torque about all points is zero. So this is something you need to remember. You could have taken the torques about any point and it would have come out to be okay. Next, if you don't have an equilibrium condition, then you can use tau equals I alpha equations for analysis. So how does that work? So you can take torques about any axis of rotation, by the way. However, you have to make sure that that axis of rotation or lies on a point which is inertial. Then you can apply tau equals I alpha equations. So first of all, the easiest way to apply this is we will prefer to apply this. Okay, apply this equation about the axis of rotation. So that's the first thing that you want to do. You can apply this approach from about the axis of rotation. If you apply about the axis of rotation, then you can say that summation of all taus about axis of rotation would be equal to the I of axis of rotation times alpha. So please remember that when you're applying this equation, you're applying it correctly. So if you're not applying it about the axis of rotation, see what are the advantages of applying the equation about axis of rotation. So first is that any point on the axis of rotation is going to be an inertial point. If suppose you choose some other point than the axis of rotation, you are trying to apply the tau equals I alpha equation about some other point, then you need to be careful if your point is inertial or not. You can also apply this always about, you can always apply this equation. This equation can also be applied about the ICM or a parallel axis passing through the CM. So please remember these pointers. This equation can also be applied about ICM or axis passing through the CM. Okay. So about that also you could have written summation tau about CM would be equal to about the CM because ICM times alpha. This will always work. However, what if you want to choose another point? If you want to choose another point, then you must take care. If that point is non-inertial, then you have to include pseudo torques in the equation. Okay, what is a pseudo torque? Pseudo torque would be the torque provided by the pseudo force when you are applying this equation in the reference frame of a non-inertial point. So please remember, that is why you would want to avoid that altogether. So the simplest approach is either apply it about the axis of rotation or apply it about the CM. Then you don't have to worry about the pseudo torques. Why is so? So let's consider that also. Yeah, I think I have left another page for this. To apply this equation, please remember, to apply this equation about any other point lying on the body, first of all, on the rigid body. So you know that I have already told you that the equation tau equals I alpha works only for pure rotation. Okay. Otherwise, what you need to do is you will apply equation of tau equals uh, dl by dt, and I hope you remember how to write dl. Okay. However, if you're taking a point which lies on the rigid body, then in reference frame of that point, obviously the entire body will perform pure rotation. We have already discussed that. That is a property of the rigid body, that you can go into the reference frame of any point of the rigid body, and all the other points would be performing pure rotation about that point in the reference frame of that point. So you could have applied this equation tau equals I alpha in the reference frame of any other point also lying on the rigid body. However, to apply this equation about any other point on the rigid body, we must also include the pseudo torques if that point is non-inertial. So mostly, if your body is performing pure rotation, if you take any point which does not lie on the axis of rotation, it will be a non-inertial point. Why? Because of rotation, it will have one acceleration, which is definitely going to be the centripetal acceleration, right? So since it already has an acceleration, it will be a non-inertial point if that point is non-inertial. So which would be the case in most of your points. Okay. So what is pseudo torque? Pseudo torque is the torque which would come into play due to the pseudo force. So whenever you are analyzing something in from a non-inertial reference frame, you know that you have to apply pseudo forces. Otherwise, your equations of Newton's laws do not work. Okay, so it's just right about that also slightly. Okay, let's define that. Pseudo torque, pseudo torque is the torque due to pseudo force. Now, how do you calculate the torque of the pseudo force? So first, you need to remember that pseudo forces will always act on the CM of the rigid body. They always act on the center of mass. Okay. So any pseudo torque would, you just apply the pseudo force at the CM and then calculate the torque due to that force about the axis about which you're planning to use the tau equals I alpha equation. Okay, so let's just write that. To calculate pseudo torque, okay, so let's write that. Calculate pseudo torque. Apply a pseudo force on the CM of the object. And take its torque. So that will be the pseudo torque that we are talking about. Now, once you've included that, then about any point you can apply R tau equals I alpha equation. Okay, please remember this. So suppose let's draw ourselves a rigid body. Here is a rigid body, randomly shaped rigid body, which has this axis of rotation. Okay, draw ourselves rotation. Let's say it passes through this point, okay, right here. And suppose if I wanted to go into the reference frame of some other point other than ones lying on this axis of rotation, then what do I do? So very simple. So let's suppose I want to apply tau equals I alpha equation about an axis which is like this, passing through this point. So let's say this is the point P about which the body is actually rotating with some angular velocity omega. Now, if you go into the reference point of a reference frame of another random point, so let's say I went into the reference frame of point A, then in the reference frame of point A, you would have seen the entire body performing pure rotation about this axis, okay, AA dash. Let's call this axis AA dash. You would have seen the body doing pure rotation about this axis, right? Now, what you will do is because this point will have some kind of acceleration, it may have a tangential acceleration or it may also have a centripetal acceleration or both at the same time. Then you will find the net acceleration of this. You would apply a pseudo force on the CM. So let's say your CM lies somewhere here. This is your CM. You would have applied a pseudo force here. So if this point itself in the ground frame has an acceleration, let's say a vector like this. It had an acceleration of a vector like this, then you would have applied a pseudo force of this here. Okay, so that would be minus times m a vector. This is the pseudo force. Okay, then while taking the torques about this axis, all you need to do is include the torque of this pseudo force. Okay, so here you could have written summation of all tau real plus tau due to pseudo force. This would have been equal to IAA dash alpha vector. This is the form in which you could have used this. So please remember that the problems of rotation are tricky because you need to take into consideration a lot of factors. Okay, so always remember, if you want to avoid all this, what is the easiest way? The easiest way is this: apply the tau equals I alpha equation about the axis of rotation only. Then you don't have to worry about it. You can also apply this equation about an axis passing through the CM. Why that? Think about it. The pseudo force, any kind of pseudo force, is always applied on the CM itself. Now, if an axis passes through the CM itself, then you will realize that this pseudo force can never produce any torque about the CM. Okay, that is why about an axis passing through the CM, you don't have to worry about the pseudo torques, and you can directly apply tau equals I alpha equations about the axis passing through CM. But that can always be avoided. Okay, and usually it is the safest to apply this equation about the axis of rotation. Okay, try and stick to this and you won't have to worry about anything else. So any at any point, the mistake that usually students make is if they don't use this equation about the axis of rotation. Okay, if they sometimes may apply this equation about some other point and then get the wrong answer because that other point might be non-inertial like this and they did not use this pseudo torque. So if you use this term in your equation about a non-inertial point also, then also you will always get the right result. Okay, so this is one way of analyzing tau equals I alpha equation. Okay, just remember how to apply these equations correctly and you will be fine. Next, of course, you have conservation of angular momentum equations. So that is yet another approach that I'll have while solving my problems. Okay, so when can I apply this? Please remember that this approach can be applied if the torque about any axis or a point is zero. Okay, so always check for this condition. Apply this approach about a point or axis about which summation tau external becomes 0. Please remember, you do not apply the conservation of angular momentum about any axis or any point. Okay, you will need to check first whether about that point or axis is the angular momentum, is the external torque 0. Yes, if the external torque is 0, then you know that the angular momentum will remain conserved. And if we are talking about the axis of rotation, then you can easily write this, because then you don't have to worry about pseudo torques. So also take care, also take care that the axis does not pass through non-inertial points. So if the axis was passing through non-inertial points, then you would have had a problem. Even if summation tau external was 0, about that axis you cannot apply the conservation of angular momentum. Why? Because there will be a pseudo torque. Okay. So what is the safest way to apply this? Again, best approach is, best way to apply this is about the axis of rotation, because that will always be inertial. Axis of rotation for pure rotation will pass through points which are at rest in the ground frame or in any reference frame for that matter. In any reference frame, what is the axis of rotation? The points lying on which are at rest with respect to that reference frame. That is called the axis of rotation. Okay. So if the axis of rotation is inertial in your reference frame, then you can apply this for the axis of rotation if summation tau external is 0. Then how do you use this? You will say I about axis of rotation omega 1 would be equal to, or I1 rather, I1 about axis of rotation. I'm assuming here that the axis of rotation is not changing. Only the moment of inertia about it may change due to certain factors. We will again consider some questions to understand this better. So don't worry if you don't follow what exactly I mean, that I1 and I2, how is the moment of inertia changing? So there may be a lot of factors because of which the moment of inertia may change. But the safest bet is, if you see at summation tau is 0, then you can apply the conservation of angular momentum about the axis of rotation for that. So I am telling you what all works and how it works. So pay attention to what all works while you are doing your analysis and how exactly should you apply it. Okay, so see, half the problem is because students don't realize what all works when. Okay. Second part is, even if they realize something is working, they don't know how to use it correctly. So if you know what applies when, and if you know how to use it correctly, trust me, there will be no problem in a rotation that you won't be able to solve. Okay. So finally, you have the work energy analysis. So work done by a torque is defined as integral of tau du theta. So just like work done by a force is defined as integral of F dot ds. So here, the work due to a torque is always defined as integral of tau dot d theta. So you can calculate the work, okay, done by a torque, and power of a torque will be defined as tau dot omega. And once you know the work, you can apply work energy theorem. Work energy theorem works exactly the same way. Okay, so work energy theorem remains unchanged. So work energy theorem would simply say that work done by a torque would be equal to change in kinetic energy of rotation. So when torques do work, they change the rotational kinetic energy. Okay, we will discuss about this also, that a body can have two kinds of kinetic energies, one rotational and one translation. Okay, so when a body was translating, then the kinetic energy associated with it was called translational kinetic energy. If a body is performing pure rotation, then the kinetic energy associated with it is called the rotational kinetic energy. Now, whenever torques do work, they change rotational kinetic energy. So when you're applying work energy theorem, you need to use the form that work done by a torque will be equal to the change in the rotational kinetic energy. Okay. And you already know that kinetic energy of pure rotation is given as half I omega square. So what you will do here is, how do you apply this approach? So find the work done by the torque about the axis of rotation. Okay, always do that. So work done by torques about axis of rotation. Always calculate the work done about axis of rotation again. Why that is needed? So that you do not worry about pseudo torques. Okay, and this will be equal to delta K about axis of rotation. So when calculating the K, again use the I as I of axis of rotation. Okay, remember that. And as long as you're doing all these things right, don't worry, you will always get the answers. Okay, you can never go wrong. Again, as I keep saying, the only problem is that we don't know often. We may find the work about some axis, we may find the kinetic energy about another axis, so that may be an issue. We may try to find the work about an axis which passes through non-inertial points, where we forget to take the work done due to pseudo torques. So that may be an issue where you might be going wrong. So you just need to be very, very, very careful while solving the problems of pure rotation, especially the advanced level problems. Okay, mains level problems and board level problems usually will be solved very straightforwardly, which you probably keep doing all the time subconsciously without realizing that you are already taking care of all these things. But advanced problems may confuse you, okay, and that is where you may go wrong. So take care of these things, and trust me, you will never be having any problem. So why don't we take an example? Okay. So here you've been told that two blocks are connected by a massless string moving over a pulley of mass capital M and radius capital R as shown in the figure. Find out the acceleration of the two blocks and the tensions in the two strings on both the sides as shown. So here you have a mass M1 and here you have a mass M2. Now note that in this kind of question, the string will not slip over the pulley. Okay, so it will be given string does not slip over the pulley. So how will that happen? There has to be friction between the string and the pulley. So because of that friction, even if you had a massless string, the tensions on both the sides of the strings would be different. Okay, please remember that. So how do you solve this? Take a try. Okay, try solving this. Okay. Till then, let me just grab some water. So let's just quickly solve this. Okay. Again, rotation is the trickiest topic for your entire class 11th and 12th syllabus. So make sure that you're paying attention to every small little things. Okay. What makes things so tough in rotation is those small little things that you either don't think about or you don't pay attention to. Okay, and that is where most of the students go wrong, and that is why they feel, this is such a horrible topic. We don't understand this one bit. We don't know when to apply what and how to apply it, of course. So stick to whatever I am telling you in this today's lecture, and trust me, you will never find any trouble solving any problem from. Okay. Okay, so one, you can try and solve this, and then I will show you an amazing shortcut. So I don't know who all are trying. Let me know in the chat. If you're trying this problem, let me know in the chat. Okay. So try this problem quickly and try and give me an answer. Come on. Let's find the answer to this quickly. This is a very standard problem. You will see some variations of this problem also. And trust me, if you learn how to solve one, then you can solve a lot others. Okay. So how do you do it? Okay. So I guess I should only go ahead and solve this. So first, what we will do is we will try to make the FBDs of all three constituents. So our system contains three parts, right? So I'll show you the standard way first, and then I will show you an amazing shortcut with which you will be able to solve this problem under 30 seconds. Okay, so first of all, which are the three constituents of my system? Okay, let's take a look. So one, I have this mass. Okay, then I have this mass, and then I have the pulley. The three constituents. The first very standard approach that you will find everywhere is that you draw the FBDs of all the constituent parts of the system. Okay, so let's draw the FBD of M1 first. So M1 has a tension T1 acting upwards and the force M1G acting downwards. So let's draw the FBD of M1 first. So M1, here we go. So this is your M1. It is feeling a tension T1 upwards and it is feeling a downward force of M1. Correct. There are only two forces acting on this. Okay, no third force will be seen. How about M2? Let's see again about M2. M2 has tension T2 acting upwards and a force of M2G that will act downward. Right. Talk about M2 also. So for M2, I will have T2 acting upwards and 2G acting. Now let's talk about the pulley. Okay, so how about the pulley? Let's make an FPD of pulley. So when you're talking about the pulley obviously will have, or let's talk about the pulley itself. So from this clamp, it will feel a push or push. Okay, and if I draw the FBD of the pulley, then what I can say is, let's see, pulley has these forces acting. So there is tension in both the sides. The tension two acting. Then there would be an mg acting here. And then finally you would have also had some push that is coming from the clamp. Okay, some upward push coming from the plank. Okay, yes, AB, this is slightly tough, and trust me, most of the problems be tough. So if I assume I assume that clamp is pushing it upwards with some end, so this is the FBD of the pulley. Right now, the pulley is going to be in a translatory equilibrium. So what I can write the equations as are, so for the two masses, I can write. Let's assume that M1 is going down and M2 is going up. Okay, assuming that M1 was going down with some A and this guy was going up with some A. Okay, what can I say? I can say that m1g minus t1 equals 1a. That is the first equation I will be able to write. Then I'll be able to write an equation for m2. For m2, I can write 2 minus 2g equals a. That is my second equation. Okay. Now, how about the pulley? Pulley is not going up or down. It is only going to rotate. So what I'll do is I will just write the rotatory equation for it. And obviously, if the rope is not slipping, string is not slipping over the pulley, then if the rope is moving like this, then you realize the pulley will have to rotate like this. Great. Pulley would have some angular acceleration in the counterclockwise direction. So for pulley, I can say for the pulley, what I can say is that T1 minus T2 times R, this will be the net torque, right? T1 times R, okay, taking torques about the center. I'm taking the torques about C. Taking torques about C. This is what we get. If I'm taking the torques about C, then the normal reaction from the clamp and the MG, they do not get any torque. Only torque is provided by T1, which is counterclockwise, and by T2, which is clockwise. So this will be the net counterclockwise torque, and this should be equal to mr square by 2 times alpha. Okay, so pulleys can be treated as this. Okay, mr square by 2 times alpha. Agreed? Let me know if you have any problem in this equation. This will be my equation number 3. Now let's take a look at the three equations that we've got. We have three equations, however, we seem to have four unknowns, right? T1 is unknown, T2 is unknown, A is unknown, and alpha is unknown. I need another fourth equation. Fourth equation will be obtained using the constraint equation, using the fact that let's talk about this point of the string. This point of the string is going down with A, right? And if this pulley is rotating with alpha, then A is also equal to alpha R. Okay, because this is also a part of the pulley, and pulley's part will have a tangential acceleration, which is alpha R. Okay, so that is the relation that I can get between A and alpha. That is my fourth equation. Fourth equation will tell you that A equals alpha R. That is equation number 4. Now you realize I have four equations and four unknowns. Now I can solve this. Okay. So you realize again, solving these four equations would take a lot of time, a significant amount of time. So this is the long method. Okay, this is the long method, long standard method. This is the way you will see this problem being solved anywhere that you refer to. Okay, so any standard textbook will show you this long method, which is also the standard method. Now I will show you an amazing shortcut with which you can get the answer in less than 30 seconds. Okay, AP. So there's the longer method, and you realize we already talk about. You will take about let's say uh, some 20 seconds to draw the FBDs, some another 10 seconds for writing per equation. So we have already spent 1 minute, and now we have to solve this. So we will have to solve at least for 2 more minutes. Okay, I think it takes. So this problem by this method will take at least 3 minutes to solve. Right now, I'm going to reduce that time to under 30 seconds. Add a page here. And now let me show you a shortcut. Now the shortcut works on the principle that you realize that the accelerations of the two masses will be independent of the length of the strings. First, you need to answer me this. Does the acceleration of the masses depend on the length of the strings? Tell me, what do you think? Does the acceleration depend on the length of the strings? So in this problem, if your strings were way longer, okay, if your strings were way longer or your strings were way shorter, would that have changed the answer? So imagine instead of this, if you had longer strings, it was like this, then would the answer change? Also, if these strings were shorter, would the answer change? So in one case, you know that M1 is here, M2 is here. The second case, I'm asking if the M1 was here and M2 was here. And in the third case, if M1 was here, if the string was cut shorter, would the answer change? No, no, the answer will not change. No, so would be same. See, the length of the string does not matter because none of your equations would have changed, right? Your strings, be it of any length, would be applying the same amount of tension. You would have gotten the same equations. If you're getting the same equations, you would have gotten the same answer also. Okay. I hope you realize that. That changing the length of the strings does not change any of my equations. So I know that the answer would be independent of the length of the string. Okay, so that's the logic. So the trick is now here comes the trick. So since I hope you understand this. So now comes the trick. Okay, trick is make the lengths of the strings a zero. Okay, so that is going to be the trick. And now let's see at the situation. Now let's see what happens now. And assume that these masses are point masses. Now let's see how the thing looks. So you will realize that you will have M1 here, M2 here, and now let's study all the external forces. So you would have had M1G here, you would have had M2G here, you would have had the MG acting here, and you would have had the same N acting here. Right. Now again, just take the torques of the system about C. So taking torques about C, let's see what that gets us now. Torques about C. So the only external torque would be due to M1 and M2 Gs. Okay, so I will write the equation that M1 minus M2 times GR, this is the net torque, and this should be equal to total I of the system. Now, total moment of inertia of the system about an axis passing through C, how much will that be? That would have been mr square over 2 plus m1r square plus m2r square times alpha. Right? So all you need to do is cancel this out, take one r common, and you will get alpha r equals to m1 minus m2 over m plus 2 m1 plus m2. And I know alpha r is nothing but a. So this is how I get the quickest answer. So only I have to make only one FBD, write one equation and solve this. Okay. Now you can definitely go back to the previous page and solve all these four equations and confirm whether the expression that you get after solving these four equations is the same as the one that we are getting here. So I hope you now realize that this is a very powerful trick. This will help you save a lot of time in such a competitive exam, and this is an advanced level problem. And if you are able to solve an advanced level problem using a trick within 30 seconds, trust me, with some practice, trust me, you will be able to write these equations directly. Now after so much practice, when I was a student, I could just give the answer orally. You just draw me the diagram, and I could orally recite you the answer because I know what I have to do. I have to write the total torque upon total moment of inertia. That's about it. That is how I'm getting alpha. Okay. So let me know if you guys followed this trick. Okay. Let me know your reactions. Come on. I'm telling you this super amazing trick. This is my personal trick, which I had, let's say, discovered when I was preparing for IIT JEE. You will not find this trick in any book. I don't think anybody else will tell you about this trick because I personally developed this as a student. Okay, so this is my own trick, my personal trick. Okay, this is not something that you will find easily anywhere. Okay, and if anybody else tells you this trick, then chances are that they got to know somehow from me or from some of my students. Trust me. Because I've been teaching for a long, long time. I've known a lot of people. Nobody tells you this trick. My own personal trick, which I had developed. All right, great. So let's move on to another typical problem of pure rotation. This is another very interesting problem, and let's see what this says. This says a rod is pivoted at one end about a point O. So as you can see, now the other edge of the rod is suspended from a ceiling through a rope as shown. Okay. Now, if the rope is suddenly cut, then find the angular acceleration of the rod. Okay. Another typical pure rotation problem. Okay, you have to find the angular acceleration immediately after the rod is cut. Okay, I will also show you some challenge problems later. Okay, I just remembered I have a variety of challenge problems about this. This problem reminded me of some very interesting problems and situations. So let's try this first, and at the end of all the problems, I will give you some challenge problems as homework. Try them, and you can leave the answers in the comment section. Okay. So first, how do we approach this? How do we approach this? So try and tell me about this then. How do you think you will approach this problem? Again, trust me, one of the trickiest topics of class 11th and 12th syllabus. Thank you. Thank you so much. And I am trying to make it as easy for you as possible. Okay, so try and approach this. How do we approach this problem? Try and tell me. What do you think? So what you need to do is first let's draw an FPD, right? Always that is going to be standard approach for solving any problem. I always draw an FPD. That is why I laid so much emphasis on drawing FPDs correctly when I taught you Newton's laws. Okay. So what are the forces that you see acting on this? So you will have one tension, and then you will have mg, and then you will have some normal reaction. And interestingly, the normal reaction could have had any direction, by the way. But in this case, the normal reaction would have only this direction. Okay. Now, please note that normal reactions from hinges can have any direction. Vertical is not linear. That. Let's write a note of that. And from hinges. So I hope everybody understands what a hinge is. Hinge or a pivot. Okay. So n from hinge or a pivot can have any direction. Okay, so though I showed it vertically, but it's not necessary. In this particular case, it will be vertical because you realize there are no horizontal forces, and if there are no horizontal forces, the normal would also cannot have a horizontal component. Otherwise, you would have had an unbalanced force in the horizontal direction. Okay, so that is why in this case, it does not have any. any horizontal component, but in general, it can, the normal reaction from a hinge can have a normal as well as a vertical as well as a horizontal component. Okay. So now, what do you think will happen if I cut this suddenly? So if this string is cut suddenly, you realize that the tension will disappear, tension immediately becomes zero. How about the n? N I also know can change instantaneously, can change instantly, right? So the point is, I don't know what the new value of n becomes after I cut the string. I know that the tension in the string becomes zero. However, I'm not sure whether the value of n remains the same as it was before I had cut the string, or it has changed. Or if it has changed, how much it has become. So since I don't know about n, I cannot apply f equals ma equations to find the acceleration of the cm and hence the alpha. However, what I can do is I can take torques about O. First, I know O is inertial point, okay, because this point will never move. So I can take torques about, and this will be the axis of rotation. And I told you we can always take tau equals I alpha equation about the axis of rotation. In this case, that will also have another advantage that n is passing through this point O. So n will not provide any torque about O. So let's get to solving this. Taking torques about O, I hope you realize why we are taking torques about O. That is the simplest method of solving this problem. So I'm trying to tell you the simplest method. Of course, you can also solve this problem with other methods also. I could show you the solutions, but we will just stick to the simplest methods of solving. Taking torques about O, what I will realize is that the only force providing torques about O, see, whenever any force passes through a point, the torque of that force about that point is zero. I hope you remember that. Always remember that. So taking torques about O, I will see that only torque is being provided by mg, and this is roughly L by 2, where L is the total length, I'm assuming. Okay, this is roughly L by 2. I'm assuming that this is almost at the end because it has been pivoted at one edge. So I'm assuming that this is near the end only. So the only torque provided would be by mg, and that would be mg into L by 2. So how do you calculate torques? Always take force into the perpendicular distance, that is it. And for judging the direction, you judge that using the right hand thumb rule. If the torque is in the anti-clockwise direction, then you give it a plus k sign, and if it is in the clockwise direction, then you give it a minus k sign. Okay. So in case you need to write the torque vectorially, here we will avoid writing it vectorially. We will just talk about the magnitude. Magnitude is mg into L by 2, and this should be equal to I alpha. I about the axis of rotation, which is I passing through O, which will be 1 by 3 ml square. I hope you know this, into alpha. So using this equation, I will immediately get this and this get cancelled, and alpha is pg over 2l. This is my answer. Okay. Okay, so PNC says, sir, why is there no course of physics for IIT JAM on Unacademy Plus? I have no idea, PNC. See, I only teach physics for IIT JEE, so I cannot really comment on what IIT JAM, what courses on IIT JAM are happening. Okay, maybe you, I did not even know this, that there are no courses on physics for IIT JAM. Maybe you can get in touch with the support team and give a suggestion. I don't know. All right. I hope everybody followed this, by the way. This is the simplest approach. This is how you can easily find the alpha in this case. Okay. Again, there are other approaches also. Instead of taking thoughts about, oh, you could have done a lot of other things. But we are not going to get into that. I don't want to confuse you anymore. I want you to use the simplest approaches for all the questions. Okay. Now let's talk about another. So these two problems we solved by using tau equals I alpha equations. Okay, so abhi JAM is the admission test for management. Okay, IIT JAM is joint admission test for management, I think. Okay, I think if I remember it correctly, JAM was management. I'm not really sure. I'm not really sure. I was never interested in taking the IIT Jam exam, so I never did too much research. I think for I don't know. So I am not the perfect person to comment on that. Okay. Okay. So Jam is joint admission test for MSc. Oh, okay. Okay. I know about GATE. GATE is for MTech. So a lot of people in IIT would take the GATE exam. Jam, okay, Jam is for MSc. Hi Arun Kumar, how are you? You can do MSc after qualifying Jam and from famous IITs of India. Yes, I know a lot of people in the teaching field are MScs from IITs. So I think yeah, it does work fine. I think it may be definitely worth it from what I've heard from people. The IITs have good research labs compared to other colleges. So better, definitely better equipped labs because of the great budget that they get. So I'm sure if you're planning to do an MSc, it's always better to do MSc from IIT. I think so. Yes, of course. I did not needed that exam. That is why I did not know about that exam. Okay. All right, PNC. Okay, how about this question? So two questions we solved using tau equals I alpha equations, and by now I hope you know how to use the tau equals I alpha equations correctly. In this problem, you've been told a man standing on a turntable is rotating at a certain angular frequency with his arms outstretched. Now, if he suddenly folds his arms, Now he suddenly folds his arms, and if his moment of inertia with folded arms is 75% of that with outstretched arms, then the rotational kinetic energy will be. Yes, 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 yes. Okay, I did not know that. See, a lot of my colleagues or a lot of people in the teaching industry have done their MScs from IITs. So I know, definitely it. Again, as I said, so mainly in masters you need a lot of good labs and practicals. The IIT I think will provide you with some of the best facilities for that. I think if you plan to do MSc, then definitely worth it doing doing it from IIT. Also, you have an advantage if you want to come into teaching. Okay, a lot of people which teach, they just say that they have studied from IIT. So you will get some extra credit in IIT JEE coaching industry because you are from IIT. तो प्लस में तो आपने बहुत कम लेक्चर रखे हैं। नहीं, ऐसा तो नहीं है। प्लस में आई हैव रेगुलर कोर्सेज, आई हैव वन लेक्चर डेली ऑन यूट्यूब आल्सो आई हैव वन लेक्चर डेली। आई डोंट नो व्हाट यू मीन बाय दैट, यशोदा। So in plus what I plan to do, if you're talking about rotation, I don't know, are you talking about rotation specifically? See, in plus what I have planned is that I will have special sessions of problem discussion. So those lectures which you're talking about are probably only for theory. Okay, ये है अंतर. Here in these lectures, we are discussing the problems as well as theory together. So there, I think the way I've planned it is, हाँ वही बोल रहा हूँ, वहां पे क्या है, वहां पे the way I've planned it is, we will discuss the theory in one lecture, फिर एक special class रखूंगा जिसमें problem discussion होगा, फिर theory in the scheduled lecture, then special class में problem discussion, like that. तो अगर उसमें मैंने let's say 7-8 लेक्चर रखे हैं और तो that would essentially mean around 16 classes. Okay, so that was the point. वहां पे वो टॉपिक्स, वो जो लेक्चर्स आप देख रहे हो, that is only for theory discussion. ओके, प्रैक्टिस के लिए स्पेशल क्लासेस में प्रैक्टिस सेशंस करूंगा सो दैट एवरीबडी कैन ज्वाइन आल्सो, सब आके प्रैक्टिस कर सके, यू फील मोर कंपटीशन आल्सो ड्यूरिंग प्रैक्टिस सेशंस. ओके, सो ये अंतर है। ऑलराइट, हाउ अबाउट दिस क्वेश्चन, भाई ये कैसे होगा? बहुत ही सिंपल था बाय द वे। आपको पता है कि यू हैव बीन टोल्ड दैट दिस इज द this is the problem where you can apply angular momentum conservation, as I told you initially. That इसमें क्या हो रहा है, बंदा घूम रहा है, बंदे ने घूमते घूमते ऐसे हाथ स्ट्रेच कर रखे थे, and then he folds his arms, right? So when he folds his arms, what happens is that the moment of inertia is changing and there is no external torque on the system, right? कोई बाहर से आके कुछ नहीं कर रहा है, बंदे ने बस अपने आर्म्स फोल्ड कर लिए। Okay, so since there is no external torque on the system, since there is no external torque on the system, therefore I can conclude the angular momentum, the angular momentum of the system will remain conserved. Now, whenever I want to apply angular momentum conservation, I've told you the trick. I omega 1, I1 omega 1 equals I2 omega 2. That is what you can apply. So let's imagine. Let's imagine if initial I was I1 and omega 1, then I can say that I1 omega 1 would be equal to I2 omega 2. Okay. And what have you been told? You have been told that I2 equals 0.75 I1, है ना, ये given था. So from here I can say therefore omega 2 कितना हो जाएगा, omega 2 would be omega 1 over or into 4/3, है ना, सही है. Okay, next, what is K1? K1 would be half I1 omega 1 square, that is the initial kinetic energy. How about K2? K2 would be half to I2 into omega 2 square. तो उसमें जरा वैल्यूज डाल देते हैं. So this will be half into P by 4 times I1 into 4 by 3 omega 1 whole square. So what you will realize is therefore तो K2 होगा, K2 is 4 by 3 times K1. Okay, तो कौन सा आंसर सही है भाई? Option number A, increases by 33.3%. Okay, so that is the correct answer. So this was a problem where you solved the question using the conservation of angular momentum. So I am trying to take up every type of problem. Okay, now let's try another problem. एक और problem try करते हैं. आपको बोला है a meter scale AB is held vertically with one end A hinged at the on the floor. Now it starts falling on its own from rest. You find the velocity with which the end B strikes the floor. ठीक है, इसको ऐसे में छोड़ दिया हमने एंड ये ऐसे गिरेगा. तो जब ये ऐसा जस्ट अबाउट व्हेन बी इज जस्ट अबाउट टू हिट द फ्लोर, तब इसका स्पीड क्या होगा? will be the speed of end B when it is just about to hit the floor. ये एक और typical problem है. This is another typical problem of pure rotation. So how do you approach this? सोचो इसके बारे में. अब इसमें हम देखो equations क्या क्या लगा सकते हैं. So first I could have applied tau equals I alpha kind of equation, but you realize as the orientation of the rod will change, you realize भाई टॉर्क किसका लग रहा है. एक तो यहाँ कुछ mg लगेगा पूरे टाइम और एक यहाँ से n लगेगा. n के यहाँ पर आप देखोगे हॉरिजॉन्टल कंपोनेंट्स भी होंगे. क्यों होंगे सोचो भाई. एक्सेलरेशन कैसा होगा? व्हाट विल बी द डायरेक्शन ऑफ एक्सेलरेशन ऑफ द सेंटर ऑफ मास? The acceleration of center of mass always will be like this, tangential to the perpendicular to the rod, right? So you realize it has a horizontal component as well as a vertical component, ACMX and ACY. ये ACX कहाँ से आ रहा है? कोई तो एक्सटर्नल फोर्स होगा एक्स डायरेक्शन में. कहाँ से आ रहा होगा? हिंज. So hinge in this case will provide you two components of normal reaction. कौन से डायरेक्शन में? एक तो इधर और एक इधर. इन दो कंपोनेंट दे रहा होगा, एक एन वाई और एक एन एक्स। ये एन एक्स जो है, दिस इज रिस्पॉन्सिबल फॉर दिस एक्सेलरेशन, एन वाई एंड एम जी combined are responsible for this. Yes. In any case, so you realize the problem is, एक तो यार मुझे hinge के forces नहीं पता. So either I take the torques about the hinge. But if I start taking torques about the hinge, तो जैसे से ये थीटा चेंज हो रहा है, ये टॉर्क भी कॉन्स्टेंटली चेंज हो रहा है. तो टॉर्क भी चेंज हो रहा है, मुझे इंटीग्रेट करना पड़ेगा, बहुत सारा झंझट है. और क्या लगा सकते, और क्या लगा सकते. अच्छा, इसमें एक चीज और बोल दो कि फ्रिक्शन नहीं है. अज्यूम नो फ्रिक्शन, ये भी देना चाहिए. वैसे वो अंडरस्टूड होता है, इट्स सपोज टू बी अंडरस्टूड, बट ठीक है. You should. It's always better if it's mentioned. So now, since there is no friction, एक बात बताओ, which torque is going to do work? There is only one torque which is going to do work, and that torque is of mg, right? So what I can do is I can apply a work energy theorem. Okay, if mg का torque है, conservative forces का torque हम अगर ignore कर दें, तो मैं energy conservation लगा सकता हूँ. Okay, आई कैन सिंपली से जो भी ये नीचे आया, जब इधर से इधर आया, तो एमजी के टॉर्क ने कितना वर्क किया, जितना भी लॉस ऑफ पोटेंशियल एनर्जी है. ओके, एमजी के टॉर्क, एमजी का वर्क हमें हमेशा पता है. ठीक है, एमजी का वर्क हमेशा ही लॉस ऑफ पोटेंशियल एनर्जी होगा, एंड दैट लॉस ऑफ पोटेंशियल एनर्जी वुड बी इक्वल टू गेन इन काइनेटिक एनर्जी. So in this case, when I solve, I apply work energy theorem because that is the easiest way to solve this. Okay, so since और वर्क एनर्जी थ्योरम कब लगाते हैं, जब भी कोई एनर्जी कंजर्वेशन कब लगाते हैं, जब भी कोई नॉन कंजर्वेटिव फोर्स नहीं हो. सिंस no non-conservative force is doing any work, energy conservation can be applied, right? तो आपको ये पता होना चाहिए क्या लगा रहे हैं और क्यों लगा रहे हैं, उसका करेक्ट लॉजिक भी पता होना चाहिए. एनर्जी कंजर्वेशन कैन बी अप्लाइड. देखो, ये एक एडवांटेज होता है सब्जेक्टिव क्वेश्चन सॉल्व करने से. तो आई टुक माई जेई व्हेन इट वाज सब्जेक्टिव, सो there you could not just solve and give the answer. You had to write all the steps, you have to explain why you're doing something, so that strengthens your own concepts. Okay, makes your concepts strong. Not only are you applying anything, you are also explaining why you are applying a particular thing. So in this case, since there are no non-conservative forces, then I know that no, energy conservation can be applied, and therefore I have. So if I talk about this position and if I talk about this position, now please remember one thing, potential energy जब लोगे तो center of gravity का height देखते हैं. ओके, जस्ट रिमेंबर दैट. ये एक और गलती है जो लोग करते हैं. सेंटर ऑफ ग्रेविटी भाई यहाँ था L/2 पर, और अब यहाँ आ गया फाइनल क्वेश्चन में सेंटर ऑफ ग्रेविटी कितना नीचे आया है. तो प्लीज नोट, आप एक नोट बना लो. नोट, व्हेनेवर यू कैलकुलेटिंग डेल्टा पी इज एम जी टाइम्स डेल्टा एच सी जी. हमेशा सेंटर ऑफ ग्रेविटी का हाइट का डिफरेंस देखोगे. ठीक है, सो यहाँ पर कितना हुआ, mgl/2. दिस इज दी लॉस ऑफ पोटेंशियल एनर्जी. इट शुड बी इक्वल टू गेन इन काइनेटिक एनर्जी. तो गेन इन काइनेटिक एनर्जी कितना होगा, हम मान लेंगे कि जब ये यहाँ हिट हो रहा है तो इट हैज सम ओमेगा. ओके, कुछ ओमेगा आ गया इसके पास, कुछ एंगुलर वेलोसिटी आ गई, तो रोटेशनल काइनेटिक एनर्जी आ गई इसकी वजह से. रोटेशनल काइनेटिक एनर्जी आई ऑलरेडी नो हाउ टू राइट, दैट वुड बी आई AOR axis of rotation times omega square. Okay, so I will substitute these values. So I will write mg times L/2 should be equal to half into I. About axis of rotation वो कितना हो गया, half ml 1/3 ml square to omega. This and this will get cancelled. This will get cancelled, and I will get this will get cancelled. That times equals, and omega times L. This is the velocity of end. Pg. 30 meter per second would have been the velocity. Okay, got it? In any case, this was a meter stick. So L was 1 in case I needed that also. But turns out I don't. Okay, ये समझ में आ गया. Let me know if you guys followed this. So again, let's take 10. So this is right up. Okay. So that is the answer for this question. Okay, I hope everybody followed this. So you should know what to apply when and how to apply. जब भी आप लिख रहे हो तो सारी की सारी एनर्जी जो है रोटेशनल है. रोटेशनल काइनेटिक एनर्जी कैसे लिखोगे? रोटेशनल काइनेटिक एनर्जी would be half I about axis of rotation times omega square. Remember that? अच्छा अच्छा. अभी I missed the square. So this is the case. From here I can say omega equals root 30 and V of B would be equal to omega times which would be root 30. Just realize that omega, this is omega square. Okay, so this is your answer. Okay. All right, moving on. Let's take another example where we will use work energy theorem to solve our problem. In this problem, you've been told that in the figure, in the show, in the figure shown, a mass m slides down frictionless surface from a height h, and mass and strikes over strikes a rod of mass capital M. इसका mass capital M. After a collision, the mass m sticks to the rod and the rod is free to rotate in the vertical plane about an axis passing through O. Okay. You have to find the maximum angular deflection of the rod from its initial position. तो ये छोटा सा मास आया ऐसे समझो दिस इज लाइक दिस छोटा सा मास आया यहाँ से आके इसको टकराया इस पे स्टिक किया एंड दिस विल गो अप to some angle. You have to find the maximum angle to which the rod will climb to. Okay. Now, this is another very, very tricky kind of problem. A tricky सा problem है ये. So think about it. Think about it for 2 minutes and then I will show you how to solve this. Okay. Again, as I keep insisting, even if you're watching the recorded version of the lecture, then also I expect you to think about this problem for 2 minutes. There is a reason I am actually taking a pause for 2 minutes because I think majority of you guys watch the recorded lecture only. Live there are hardly too many people, and later I do. There are enough views, so I think almost 80% of you at least watch the recorded version, and only hardly 20%. So even if you're watching the recorded version, I want you to think about it for 2 minutes. Think about how you would have approached this problem, and then try to understand when I discuss whether your thinking was right or not. Okay. That is how you will develop your thinking. If you don't think for yourself, then trust me, you won't start to think. Okay. For any problem solving, you have to start thinking to develop a thinking process of your own. That is why I always encourage people to think on their own and then have a discussion with me and realize if they were thinking on the right lines or if not, where did they go wrong, so that they can improve their thought process. Okay, just listening to me explain the answers will not really help. You can listen to me 1,000 times, solve a thousand of problems. But unless you have developed your own thought process, this is what is going to help you solve a problem. Okay. Always try to work on your own thought process of problem solving. Okay. Yes, with that long speech, I hope everybody has been thinking. Okay. All right. So let's see how we would have solved this. So let's go over the question first. The question says the mass small m slides down a frictionless surface. Okay. So let's highlight the key points. Okay, mass m slides down the frictionless surface. So if it is sliding down the frictionless surface, so can I say when it has come down here, what will be the speed? I can apply energy conservation. It would come out to be root 2 GH. I hope you remember that by now. It will move with root 2 GH amount of speed. Okay. All you need to do is apply mgh equals half mv square. Okay, so when it has come down this slope, it will be moving with root 2 GH, right? Now it will collide with this rod and mass m sticks to the rod after the collision. Now, what kind of collision is that? What kind of collision is that? The collision is perfectly inelastic, right? If the collision is perfectly inelastic, so can I use energy conservation in such a collision? No, I can't. Now I have a problem. Since I can't use energy conservation in the collision, how do I know what will be the velocity when this guy strikes and sticks? So when this guy strikes and sticks, this rod will gain some omega, right? How do I calculate that omega? That is the question. So let's talk about the other approaches. So first, you go by a sequence. Whenever you're thinking about a problem, you go by a sequence. So first, always ask yourself. So keep this sequence of thought. Okay. First is energy conservation. Can it be applied? Second, momentum conservation. Can it be applied? Third, angular momentum conservation. Can that be applied? So always go in this process. Okay. So if I give these places names A, B, and let's say C, let's give the names. So between A and B, I can apply energy conservation. Why? Because the surface is frictionless. So let's start writing all the logics. So between A and B, energy conservation can be applied. ये भाई ये लगा सकते हैं. क्यों लगा रहे हैं? Again, surfaces were frictionless. ठीक है, ये ना सिर्फ ये याद रखना क्या लग रहा है, ये भी याद रखना क्या क्यों लग रहा है. क्या से ज्यादा क्यों जरूरी है. अगर क्यों समझ में आता है तो क्या लगेगा वो आराम से निकाल लोगे. ओके, सो वी. So therefore, I can immediately say V would be root 2GH. है ना भाई? ये तो पता चल गया. Now, when the collision happens, what will happen? When the collision happens, let's see how will this behave. So right after the collision, this would gain some omega, and this mass will stick to it, and this will gain some omega. Now, during that collision, can I apply energy conservation? No. Why? Because what have I been told? I have been told that the mass m sticks to the rod. When does that happen? There is no velocity of separation. Yes, Q is very, very important. Okay. Mass sticks. So if the mass is sticking, this kind of collision is inelastic. In inelastic collisions, we know that energy is not conserved. Now for the collision, energy conservation cannot be applied. And again, why it can't be applied? As this is an inelastic collision. I hope everybody should remember this, that in inelastic collisions, There is always energy loss, right? Next, so no, this cannot be applied. Okay, so let's move on to this. So we will always start from here, and if this can be applied, I will directly use this. If this cannot be applied, then I will move to here. Now, how about momentum conservation? Can I apply momentum conservation? Let's see what happens if I take these two as one system. If I take the rod and the mass as one system, can I apply momentum conservation? What do you think? Can I apply momentum conservation on the system? Turns out no. See, when can you apply momentum conservation? If there is no external impulsive force in a system during collision. However, during this collision, you will have an impulsive normal reaction which will come from this hinge. An impulsive. You would have had an impulsive normal reaction coming from this hinge. Right? If this was not hinged, then when this collides, this would not have stuck here. No, it would have just moved. It would have moved forward, right? Or done something weird, but this end would not be fixed here. So to keep this end fixed, when the collision is happening, this point has to apply some kind of a normal impulsive normal reaction to keep that point O fixed in its place. Okay, so even momentum conservation can also not be applied. Okay, now I have a problem in most of my collision problems. I know I used to solve it using momentum conservation, right? And here in this particular case, the hinge is providing an external impulse to my rod and the block system. So momentum conservation is out of the question. Okay. Let's write that also. For collision, for collision, P conservation can also not be applied. Again, why? As hinge will provide an external impulse during collision. So, okay, no, this also cannot be applied. Now, what do I go? Now is the third possibility that I will explore. Okay, so always take this approach. Always start with energy conservation because that is the easiest to apply. So, if energy conservation can be applied, solve with energy conservation. If energy conservation doesn't work, go for momentum conservation. If momentum conservation does not work, then look for angular momentum conservation. Now, can angular momentum conservation be applied? So, angular momentum conservation, if you remember, can be applied about any point about which there is no external impulsive torque, right? Can you find such a point? Yes, you can. About O. So, there is only one external impulse that I'm getting, and that is passing through O. So, obviously, about O, there will be no external impulsive torque, right? There is only one external impulse. So, if I take any point about which this external impulse is passing, about that point there will be no external impulsive torque. So yes, about such a point, angular momentum conservation can be applied. In fact, you will realize one thing. You could have applied angular momentum conservation about any point lying on this entire line. But we will not get into that. It's for your advanced level understanding though. If you take this entire line, you could have taken this entire line and you would have realized that about this entire line, about any point of this entire line, the torque of n would be zero. You could have applied angular momentum conservation about any of these points lying on this entire line. However, what is the most convenient point? So these are the possible points. The most convenient point, of course, is O only. So in problem solving, we will always apply it about O. But let me tell you, it would have worked if you would have applied it about this point also, any goddamn point on this entire line. Okay. That is just for your understanding. So now I can say, however, now I know what to apply. So the entire trick is figuring out what will work for collision. For collision, for collision, angular momentum conservation can be applied about O. So that is how you should think. Because a lot of students ask me that only. कि सर ठीक है ये लगा लिया बट हमको कैसे पता था ये लगाना है? How do I know that I have to apply angular momentum conservation? Why not energy? Why not momentum? That is why I'm showing you all these steps about how you would have thought of this. About O can be applied about O. Okay, so now when I apply angular momentum conservation apply about O, what is the initial angular momentum? Okay, so I think I will need to add one page here. So what is the initial angular momentum about O? L initial about O would have been equal to small m times root 2 gh times L, MVR. MVR perpendicular. I hope you remember that. The direction is easy to judge since it is going like this, so the direction would be into the plane of paper. What is the angular momentum final about O? Finally, this setup will be rotating with some omega. So I about O times omega. Okay. So I about O of the system times omega. So I can equate these because the angular momentum has to remain conserved. Therefore, I can say m times root 2 gh L, where L is the length of the rod. Somewhere not mentioned anyways. We will assume that the length of the rod is L. And this should be equal to I. I would be the I of the rod should be 1 by 3 ml square plus the point mass being stuck at the end. This. Now that would have given me omega. Okay, so let's just stick to that only. This is I about O times this to 2G. Now I can apply energy right after the collision. Now after the collision, once it starts to rise, now there is no non-conservative force. Okay, after collision, energy conservation can be applied. Okay, and what would that give me? That would have given me that half I naught omega square. This is the entire kinetic energy. And this would have gotten converted into if this goes up by an angle theta, what is the gain in potential energy? So if this goes up by an angle of theta, you would have realized this would have come up by this. Okay. So here this would be L by 2 cos theta. So this mass of the rod, center of gravity of the rod, delta H Eg for rod, कितना होगा? That would be L times 1 minus cos of the L by 2 times cos of 1. And delta H for M. Also delta H for M. How much would that be? That would be L times 1 minus cos theta. Okay, so all this kinetic energy would have gone into potential energy. Okay, and that I can write as half I omega naught square should be equal to m times L by 2, 1 minus cos theta times plus m times L times 1 minus cos theta times. So now I can solve this equation and find theta. So this is a very tricky problem, not a very simple problem. Okay, it takes a lot of thinking and some amount of calculation also to solve. Okay, but I hope you followed all these steps and now you will be able to find the correct answer. Okay, this is how you would have gone about this, right? I'm leaving it at this point because we are running out of time. I hope you figured how you would have solved it. You could have calculated the values from the above equation, substituted them here, and found the value of theta. Now here is another problem, which is I give it to you as your homework problem. Okay, a rod is hinged at one point, is released from a horizontal position, so it is like this. I am releasing it like this. The moment it becomes vertical, so after doing this, it becomes vertical. The lower half breaks off, and the rest of the half will climb. Okay, so this half will suddenly break off, fall down. The rest of the half will keep on rotating. You have to find the angle to which this will rotate to. Okay, so this is a very good problem. Try this. Okay, maximum. You have to find the maximum angle theta in degrees to which the hinged upper half will rise to. Now, okay, another thing which I wanted to tell you was a challenge problem. It's like a challenge problem. And when I say challenge problems, these are really tough problems. Okay. So challenge problem is a square uniform square sheet. So here's the question: a uniform square sheet of mass m and side A hangs in three three situations as shown. Okay. Now pay attention to this. This is a very tricky problem, very tough problem. One of my favorites, in fact. Okay, so this is situation number A. In this, there are hinges. There are two hinges, and we are calling those hinges A and B. This is how the rod is square plate is. Okay, maybe we will draw the square plate with some of the color. Okay, in the next point, number B, we'll have slightly changed the situation. So there is one spring here and plate is hanging from the springs. Okay, identical springs, identical hinges, and in the third one is hanging from threads. In A, this is, and again you have in A and B, same plate hanging in three different configurations. Okay, so in the first one, you have ideal hinges. Ideal hinges are frictionless. Remember this. Then here you have ideal springs. Identical again, strings and ideal strings. Okay. Now, in all these situations, you have to find the alpha and the ACM immediately after the contact at B is cut. Okay. Find the ACM and alpha immediately after contact B. Okay. So this is a challenge problem. By the way, let me tell you. Okay, you think about it. You think about it, and I will discuss it after few lectures. Because in solving this particular problem, you will need to know a bit about it. Okay. So with that, I will wrap it up. We will start the discussion of analysis of general motion in the next class, and till then, you can try some more problems of pure rotation. And this is where I would like to wrap up today's session. Before I leave you, let me remind you that if you haven't gotten your Unacademy subscriptions, you should be getting them like this. Go to the plus section of your app, select your goal as IIT JEE, and click on Get Subscription button. Now, when you are redirected to the payment page, use the code RDLIFE to get a 10% off on all these fees. Okay. Enroll for the Unacademy Plus, and you can join us on the Plus. You can join us in these Plus courses, which are being taken by the Unacademy JEE English team. Okay. So 3 courses for class 11 topics, 4 courses for class 12 topics. Doesn't matter which year you are aspiring to take your JEE in. You can enroll in any of these courses. Trust me, they will help you strengthen your fundamentals and master these topics. Okay. Now, if you like today's video, then don't forget to press that like button and share it with your friends. As I keep telling you, that we guys know at Unacademy that not all the students can afford this subscription. So for those who can't afford this subscription, you don't worry. We are providing you almost the same quality content. I think the content or the teaching in my plus courses and here would be teaching would be around 95% same. There we have more time for practice and more time for discussion and of course live discussion and doubts. That is the only difference. Otherwise, don't worry. All the key concepts, every important bit is being explained to you exactly the same way. Okay, so make sure you make use of that. Make sure your friends make use of that. So share it with more and more people so that more and more people who need this can benefit. Don't forget to press the bell icon and the PDF notes of all the slides you use in today's lectures would be available for download very soon. Okay, don't forget to join the Unacademy Combat on the 22nd of November, and you can use the code RDLIVE to join it and win some exciting prizes. Again, if you're following us on the JEE English channel of YouTube, then connect with us on the Telegram app using this link. And finally, this is my code one last time, RDLIVE. Okay, so if you like my lectures, uh, if you'd like me to guide you through your IIT JEE battle, IIT JEE preparation, then you can get your Unacademy subscriptions, get enrolled in my courses, get yourself the subscription using this code and enjoy again. All right. So I hope you guys realized how to go about analysis of pure rotation, how to solve questions of pure rotation. Now go and get yourself some of your own practice. And if you have any doubts or any concept, then you can leave that in the comment section, or you can take it up with me live in the next live class. All right. With that I will take your leave. You guys.